Hello everyone, myself Sai Krishna. Today I am here to present about combustion control of boilers of subject power plant control and instrumentation. So let us discuss about combustion control briefly. What is combustion control? So here I give here are the contents that I am going to present in the presentation. I'll start with the introduction and as well as basic types of boilers, why we need boiler controls and combustion control of boilers, other things that we are going to learn in this presentation. So firstly, how does a boiler work? So we see these boilers in the thermal power plants, which are used to heat the water, which is from the coal. A boiler is a water containing vessel which transfers heat from a fuel source, that is like oil, gas or coal, into steam, which is piped to a point where it can be used to run production equipment, to sterilize and to provide heat, to steam and clean, etc. The energy given up by the steam is sufficient to convert it back in the form of water. When 100% of the steam produced is returned to be reused, that system is called closed system. Since some processes can contaminate the steam, so it is not always desirable to feed the condensate back into the boiler. A system that does not return the condensate is called an open system. So there are two types of systems in the boiler, that is open system and closed system, where closed system deals with the reuse of the steam that is produced with 100%. Let us discuss these systems. Firstly, closed system. So here you can have a picture of the closed system. We have the high efficiency of the boiler in the closed system, whereas the open system here, we have not fully. The steam cannot be reused again, since here we have a break, uh, and here the new water is always sent into the boiler. And nextly, when we have here we have the types of boilers. So there are mainly two types of boilers, that is fire tube and as well as water tube boilers. Here you can see the real pictures of the boiler and how it is heated inside the boilers. So first we discuss about fire tube boilers. Fire tube. Fire tube or fire or hot gases are directed through the inside of tubes within the boiler shell, which are surrounded by water. The tubes are arranged in the bank so that the gases can be passed through the boiler up to 4 times before passing out of the stock. This system exposes the maximum heat transfer surface to the water. The fire tube boilers are also known as shell boilers and can produce up to approximately 750 HP or 25,000 lbs of steam power per hour. 80% of boilers in use are of this configuration. So this is like mainly shell boilers are used in the, like shell boiler fire tubes are used in among the boilers. Here you can see the below there are two pictures of the fire tubes. Here one, and this is another picture of a fire tube inside a boiler. So nextly, the water tube. Fire or hot gases that are directed to and around the outside of the tube containing water, arranged in a vertical position. Water tube boilers are usually rectangular in shape and have two or more drums. The separation of steam and water takes place in the top drum, while the bottom drum serves as a collection of point for sludge. This system is usually used when more than 750 HP or 700,000 lbs of steam per hour. So at this moment of time, here we have a bottom drum that serves as a collection of sludge, and there are other designs with the special configurations adapting them to particular applications. Nextly, we discuss about here are the pictures of the water tube boilers, and here you can see that boiler bank and burners, overfire air, underfire air, lower drum, induced draft fan, as well as dust collector and economizer, steam drum and fuel tube. So in this way the water is boiled in the boilers. So why we need boiler controls? So what is the need for the controlling? Okay, we know that boiler efficiency relates the boiler's energy output to the boiler's energy input, and boiler efficiency equals to heat exported by fluid, heat provided by fluid. So the major considerations why we need boiler controls is to increase the uptime and availability, reduce fuel gas emissions, and maintain boiler safety, control operating cost. So these four are the major criteria for having these boiler controls. We will discuss one by one about these major criteria. The first one is increase uptime and availability. So why we need to increase the uptime and availability? The primary object of the most of the boilers operating is maintaining the uptime and availability. It is essential to maintain and upgrade the boiler control systems to assure steam availability. Modern controls are more reliable and can be readily adjusted to load swings caused by varying plant operations. Reduce fuel gas emissions. The failure to comply with the current emissions regulations can be as costly as loss of utilities. Government mandates are enforced by fines, threat of closure, or imprisonment will provide sufficient incentives for the plants to comply with the regulations. Thus, modernized controls are necessary. Improved in combustion efficiency means reduction in waste disposal problems, and by accurately controlling the oxygen, fuel flow, and stack temperature will see reductions in plant emission. Maintain boiler safety. So to modernize control system will have tight integration with the flame safety or burner management system to improve safety. Accessing field data, diagnostic functions, and alarms can be achieved by coupling modern electronic controls. Password security of the configuration software also assures not unintended changes can be done which can endanger your personal and equipment. Controlling operating costs. So this becomes the economic major criteria for anything. So reduction in fuel consumption, reduction in engineering installation and startup costs, and reduction in maintenance costs associated with older equipment, reduction in manpower and automatic response, provide a flexible control strategy to reduce process offset, readily data available for remote monitoring to determine process optimization, boiler efficiency, and load reduction. So these are the control operating costs which are used for the boilers to reduce economy and combustion control of for boilers. So the burner combustion control generally includes one or a combination of following methods. So here there are five methods that are excess air regulation, oxygen trim, burner modulation, air fuel cross limiting, and total heat control. So these five methods are used for the burner combustion control in the boilers. Let us discuss one by one. Firstly, excess air regulation. In the actual practice, gas, oil, coal burning, and other systems do not do a perfect job of mixing the fuel and air, even under the best achievable conditions. Additionally, complete mixing may be a lengthy process. To ensure complete combustion and reduce heat loss, excess air has to be kept within a suitable range. The regulation of excess air provides a better boiler heat transfer rate and advanced warming of flue gas problems, excess air coming out of zone of maximum efficiency, and substantial savings on fuel. Nextly, here we can see the picture of the boiler efficiency towards the excess air. And this is the loss due to unburned fuel, and this one is the loss due to heat in the stack. Here you have the zone of maximum efficiency can be achieved in this zone. Nextly, oxygen trim. When a measurement of oxygen in the flue gas is available, the combustion control mechanism can be vastly improved. Since the percentage of oxygen in the flue is closely related to the amount of excess air, by adding an oxygen trim control module, allowing tighter control on the excess air to oxygen set point for a better efficiency. Faster return to set point following disturbances like tighter control over flue emissions, compliance with the emission standards, easy incorporation of carbon monoxide or capacity override. And Here you can see the cross-limiting combustion control with a trim, and we contain the oxygen analyzer, which is desired excess air is provided to the cross-limiting module. Here it also contains air control element as well as fuel control element and combustion demand from master loop. So air pressure and flow and temperature as well as fuel and temperature is given to the cross-limiting module. And nextly, burner modulation. Modulated control is a basic improvement in controlling combustion. A continuous control signal is generated by control monitoring the steam or heat water line. Reductions in steam pressure or heat water temperature lead to an increase in fire rating. The advantages of introducing burner modulation in the combustion control include fuel and air requirements are continuously matched to the combustion demand. Steam pressure or hot water temperature is maintained within the closer tolerances. Greater boiler efficiency, weighted average fuel gas temperature is lower. In this way, the burner modulation step is important combustion control of boilers. Air fuel cross limiting. As we have seen in the earlier picture, that a cross limiting combustion control strategy ensures that there can never be a dangerous ration of air and fuel within the combustion process. This is implemented by always raising the airflow before allowing the fuel flow to increase, or by lowering the fuel flow before allowing the airflow to drop. Cross-limiting combustion control is highly effective and can easily provide the following: optimization of fuel consumption, safer operating condition by reducing risk of explosion, fast adaptation to variation in fuel and air supplies, satisfaction of the plant demand for steam. In this way, the air fuel cross limiting also has a method in the combustion control of a burner. And you can see the cross limiting combustion mechanism, the air and fuel lines as well as demand and time towards the flow. The airflow is higher than the fuel. Nextly, the total heat control. A cross-limiting combustion control strategy ensures that there can never be a dangerous ration of air and fuel within a combustion process. This is implemented by like always raising the airflow before allowing the fuel flow to increase, or by lowering the fuel flow before allowing the airflow to drop. So in this way, the combustion control having various methods, and this combustion control is very important in case of excess heat it can be produced while burning or having a combustion process, where energy of heat energy is uh, required for making it to turn into steam that in turn turns the turbine to generate electricity. So these five control methods helps in controlling the in the combustion control of boilers, and the air and fuel ratios of flow can be achieved with these five controls. And hence I conclude that these combustion control methods are very useful for the controlling of different mechanisms in the boilers, and it also increases the efficiency without wastage of energy. Since it is very efficient matter to have these practices, and the combustion control is a must and should process that should be undergone to lower the fuel flow and allowing the airflow to drop in this way. So thank you.